Hello, everyone. My name is Boris, and I'm from the Toloka crowdsourcing research group. And today I'll be telling about how to set up easy machine learning model monitoring with crowdsourcing labels. So I don't think I need to tell you a lot about why should a model be monitored, but I'm going to give this my favorite example of how data changes over time. So I think you heard about this disease called COVID. And when it happened, people started losing scent. And what happened to reviews of some products like scented candles is that before COVID, if a person is saying they feel no scent from a scented candle, then probably the product is bad, since it should be a candle with a strong smell. But after COVID, with people losing scent, there were a lot more of these reviews. And in this case, a review about no scent in a candle no longer meant the product is bad, because maybe the person just got sick. And this is a very subtle change within data, which cannot be detected from the text or anywhere in the data alone. But if you trained a model of some kind, it could break down at this point. And this is why you should monitor machine learning models, because data changes over time, the labels change over time, and so on. But if you want to do it, you have to get the ground truth answers from somewhere. So imagine the typical machine learning process on the inference side. You have some, let's imagine, images. On the input, you send them to an API, which sends them to a model, and then you save the predictions and images for later, so that you can somehow apply your monitoring toolkit. And then you give the prediction. If you wanted to get the ground truth from some crowdsourcing tool, this is how you would do. So this is the process for setting up the human in the loop, where you get the labels from people. So what you do with Toloka as an example, first you set up a data labeling project in Toloka. And then when you want to monitor the model, compute some metrics, you take the predictions from your database and the images, and you send them to a crowd of people to label. And then you can compare the labels from people with the labels from your model. In this case, you have the ground truth and you can compute the metrics. Toloka is really good for this for a couple of reasons. It's really fast, it's almost real time, and it's quite cheap. Additionally, we have a very nice API and Python client, and so you can keep all of this data labeling process stuff right next to your project in code under version control. And that's the part I like very much. So for this use case, I prepared a tiny demo project. So what it has is that there's a real computer vision model inside that's solving a very unreal task of separating images of cats and dogs. There is an API, and there's all the code to set up the data labeling pipeline. And it has a demo scenario when some predictions are made, they're labeled by the crowd, and metrics are computed. So let's take a look at this. This is the API I was talking about. You have the model, you have this nice Swagger docs, and here you can send some kind of image URL, which will be classified by model, and you will get something like this. The probabilities for the two classes we have. Under the hood, it will save it to a database, and when you run a script, which of course you would be in a real production running from some cron job or something periodically, then you get this project set up, and the predictions get sent to people, and then people label them like this. So I've set up a demo scenario where there are a bunch of dog pictures, the cat pictures, and something else. People label them, then it gets aggregated, and you have this ground truth labels like this, what people think it is, a dog or a cat, and so on. And you can compare. Here you have in the demo project a simple plot that plots the F1 score of your model, which is obtained by comparing the predictions of the model with the predictions of people. And that's really simple. Then over time, you can monitor how the quality of your model changes. Of course, in reality, you would use something like Grafana and not a hand-created gsplot, but you get the idea. One final thing is that there are caveats in this approach. It should be, it's almost not as simple as this demo, but it's a good starting point. The caveat says that the ground truth labels you obtain from people are not 100% reliable. So here are some ways you can tackle this. You could monitor the quality of the responses themselves. You can add some error bars, but the most important thing is to just keep this in mind. That's all I have for you for today. Thank you, and check out the demo.